Hello there and welcome to today's class. For today's class, we'll be discussing about integration of trigonometric function using trigonometry identity. For this concept under integration, there are about 4 cases for this one here. We have case 1, case 2, case 3 and case 4. So I'm going to be doing like 4 series video to explain this concept. But for this class, we're dealing with the case 1 that governs this concept. So don't forget I said we have case 1, case 2, case 3, and case 4 that governs the idea behind integration of trigonometric function using trigonometry identity. Alright, before I start with the case 1, right, let's discuss something important, a key concept, or perhaps let me call it a shortcut to solve some problem under integration. Let's say for instance I have let's say note number one, let's say I have the integral of sine 3x dx. If you are taught to integrate this, how do you solve this? My first priority, or perhaps my first task, is to make u, I'll call u, to be equal to what? 3x. If u is 3x, of course, if I differentiate u with respect to x, I will have the u over the x to be equal to 3. If I differentiate 3x, I'll have 3. At this point here, make the x subject. So the x is equal to, put this 3 here, put the x here, I'll have the u over 3. If 3 comes, it becomes the u over 3. So left with what? The x. At this point here, I'll substitute. What do I get? I have the integral of sine 3x. We just had 3x to be u. Sine u dot dx. What's the x? The u over 3. I have the u over 3. This can be broken down as the integral of sine u dot 1 over 3 dot du. True or false? True. 1 times the u will give the u all over this 3. So this 1 over 3 here, I'll take out this constant term, which is 1 over 3 outside the integral sign here. So I'll have 1 over 3 first. The integral sign of what? Sine u, next up du dot du. Now at this point, if I integrate sine u, I'll have minus cos u. So I'll have that. At this point, I'll have 1 over 3 into integrate sine u. I'll have minus cos u dot minus cos u. That's all. Next up, I'll have plus c. Integrate sine u with respect to the u. I'll have minus cos u. Add plus c to it. That plus c is constant. At this point here, 1 times minus cos u, I'll have minus cos u all over, I have a 3 here, all over 3 plus c. But I can see u here, but we just said earlier that u is equal to what? 3x. I have 3x here. So I'll put 3x here. I'll have that. If I integrate this one, the integral of sine 3x dx, my answer becomes minus cos, what's u? 3x, minus cos 3x all over this 3 plus c. This becomes my answer. So if I integrate sine 3x dx, my answer becomes minus cos 3x all over 3 plus c. Now, what's the idea? Observe something very important here. I'm dealing with sine. So what I want you to notice is that if I have the integral of sine ax, for instance, with respect to the x, the idea is quite simple. Don't stress yourself going through this process again. Here's a shortcut. What's the shortcut? The idea is that if I integrate sine ax, I'll have what? The minus cos ax, please. Integrate sine, I'll have minus cos. So no difference between integration and integration and differentiation. If I differentiate sine, I'll have what? The cos. But if I integrate sine, I'll have what? Minus cos. So that will be minus cos ax all over differentiate ax, I'll have a. Next up, plus c. This becomes the shortcut. Observe, please. Become the shortcut. So if I have 3x here, the idea is just change this 3 and I have 3 here. So let's see if I have the integral. If I have the integral of sine 27x dx, I'm going to integrate this. No need of going through this process. This is lengthy. What's the idea? The idea is quite simple. If I integrate sine 27x, I'll have the minus cos 27x all over differentiate 27x. I'll have 27 plus c. This becomes my answer. No time. So this is like the first note you need to note when it comes to integration of trigonometric function using trigonometric identity. This is the first task here. What about the second task? Note number 2. This one here is for the sine. The same thing that applies to the for the cos. If I have the integral of cos 3x dx, how do you integrate this? First task again, call this one u is 3x. If I relate to with respect to x, I'll have du over dx as what? As 3. Make the x subject. So the x now is equal to du all over 3 at this point. What's your next task? Substituting. If I substitute, what do you get? I have the integral, this integral symbol. Next up, cos, I have cos. We just had 3x to be u now. I'll have u here. Dot the x now is now what? Du over 3. I have du all over 3. At this point here, your next task is quite simple. I have the integral of cos u dot, this can be expressed as 1 over 3 du as explained earlier here. So from there now, I'll have the integral of cos, this is 1 over 3, a constant outside the integral sign, 1 over 3. Next up, cos u dot du. At this point here, I'll have 1 over 3 into, if I integrate cos u, I'll have what the I'll have sine u. Please note all these things. If I integrate sine x, I'll have minus cos x. If I integrate cos x, I'll have sine x. Understand this concept? So I have cos u. So with respect to the u, I'll have this one here plus c. So at this point here, your next task is quite simple. I'll multiply 1 times sine u. I'll have sine u all over this 3. Next up, plus c. But I'm not done yet. What's u? But we said u was 3x here. But we said u is equal to 3x. Put 3x here. I'll have sine 3x all over 3 plus c. So if I integrate cos 3x dx, I'll have sine 3x over 3 plus c as my answer. So the concept is still the same thing. What's the shortcut here? If I integrate cos 3x dx, the concept is quite simple. Integrate cos 3x dx. What's the concept? The concept is that if I integrate cos 3x, I'll have what? The sine 3x all over differentiate 3x, I'll have 3. Next up, plus c. That's the shortcut to that. So understand these two notes, number 1 and number 2. I just put in front right now. So understand this concept. So we use concept in our solving for case 1, case 2, 3, and 4 under the idea of integration of trigonometric function using trigonometric identity. Welcome back. Let's start with the case 1 under this concept. So case one, case one under the concept of integration of trigonometric function using trigonometric identity. Here's the case one here. If I have sine, an integral of sine ax cos bx dx, such that the value of a is greater than the value of b, so the mathematical expression becomes 1/2 integral into sine a plus b with respect to x plus sine a minus b with respect to x. I have the x here. So if I'm having something of this nature here, the mathematical expression becomes something of this nature. So example says that if I have the integral of sine 5x cos 3x dx, observe that 5 here, which is a, representing a, as you can see, and 3 here representing b, as you can see. Observe that a here is greater than what? Value of b. So it means that I'm going to express it what? In this form. So that becomes 1/2 integral into sine, I can say sine, into what? The a plus b. A plus b becomes 5 plus 3, 5 plus 3 of course x there, plus I have a plus sign there, sine into a minus b, that's 5 minus 3, 5 minus 3 of course I have x there, into the x. What's your next task? I'll have that 1/2 integral into sine, I have sine 8x, 5 plus 3 is 8 with respect to this x here, plus I have sine 2x, sorry, let's use a round bracket, alright. 5 plus 3 is 2. I have this x there, and of course with respect to the x. What's your next task? I'll pick out 1/2 and integral, this 2 here, multiply with this one, that's sine 8x. Attach this one to it, the x, I'm done. Here's a plus sign, plus. Pick out these 2 again, half and integral. Next up, sine 2x with respect to the x. Obviously, for me, my next procedure is quite simple. I'll have 1/2, this one, into, if I integrate sine 8x, I'll have what? The minus cos 8x all over, differentiate 8x, I'll have 8. So it means that if I integrate sine 8x with respect to x, I'll have minus cos 8x over 8. As we discussed earlier when I showed the shortcut for sine and cos. This for sine here. So plus 1/2 into integrate sine 2x, I'll have minus cos 2x all over 2. Next up, plus c. At this point here, my next task is quite simple. 1 time minus cos 8x becomes minus cos 8x all over 2 times 8 is 16. This is plus minus will give minus, plus minus give minus, cos 2x x all over 4. 2 times 2 gives 4 plus c. This becomes my answer after solving this problem here. This is the concept of integration of trigonometric function using the idea of trigonometric identity. So see you in the next class. Next class is about the case 2 under this concept.